Okay, let's get started. So the menu for today is a few quick announcements, and then we are going to continue our way through module 3. Okay, so inheritance, and then we should reach polymorphism, I would say probably next lecture or the one after maximum. All right, so let's start with a sort of public service announcement. So the after class chat sessions, they have been working great. When people have small questions, they just line up at the end of the lecture. This is perfect. Let's not change anything, okay? Then I've been walking back to my office, especially for the afternoon session, and I've been holding some sort of impromptu office hours there. So what I'm proposing to do is to make them official and to migrate them online. Okay, so we still have our little, quick question at the end of the lecture. I wanted to ask you this, etc. This is perfect. This works fine. In addition, on Tuesdays and Thursdays, from 7 to 8 p.m., I'll be online. Same room than usual. So there's going to be an overlap tomorrow with Ahmed. So I'll just tell Ahmed that he can take the time off. But normally there's no overlap, and if you have a daytime schedule, either AV class schedule or work schedule, that should allow you to catch somebody for office hours 3 days out of 4 weekdays. Okay, so let's get 5 weekdays. Sorry, let's give it a shot, and as usual, let me know. Give me your feedback. Okay, if that helps, that's good. If that doesn't help, you prefer another system, let me hear it. All right. PLQ, peer learning quiz, finally released. There has been some little technical delay there, but finally they're released. So the first one is going to be on pretty much what we covered last week, a little bit, the inheritance part, and what we are going to cover today. So let me tell you real quick how those PLQs are going to work, okay? So it's a quiz. There are very few questions. The point is not to have a lot of questions. The point is to double check that the most important things from the lecture are well understood. So I am going to tentatively try to have those, almost every week. So just 3 questions like that a week, to keep us on the same page on the lecture. The way that you are going to take those PLQs, unfortunately, they are not in Canvas. Canvas doesn't have this kind of feature. So we have an external tool to help us to do those particular type of quizzes. So the first step is for you to visit this URL. And like the name implies, /sign up, you're going to sign up for your free account there. You just have to do it one time, but make sure that you use your USF email address, your official USF email address at usf.edu, right? And when it asks you for your first name, last name, use the first name and last name as they appear in the gradebook, okay? That's going to make it much simpler for us to then give you the points when you participate to one of those activities. After you're done with the sign up, so sign up only once, you should have to log in also only one time, okay? If you're always using the same browser to take the PLQs, it's going to store information locally, okay? You just log in, and then it redirects you to a sort of minimalist front page. Just ignore it. This is not where you are going to take your quiz. The 2 buttons on that front page, I'll show you later. The 2 buttons on that front page are just for demo quizzes that were used while we were testing the system. So you sign up, you log in one time from your browser of choice, your preferred platform, and then you are ready to go for the rest of the semester. More specifically, regarding PLQ1, the first peer learning quiz, we are going to have 2 deadlines this week. The first deadline is Thursday, 11:59 p.m. And by the way, the deadline is something that I'm experimenting with. So again, feedback welcomed. So the first deadline is Thursday, 11:59 p.m. You are going to just click that URL. That's it. That's all you have to do. You click that URL. It's going to remember that you were logged in, if you are still using the same browser, of course. If you're on a different platform, well, you have to log in again. And then it's going to catapult you directly into step 1 of the quiz. Step 1 of the quiz looks very, very familiar. It looks like just about any quiz that you have ever taken. Let me see real quick if I can show you the page here. There we go. No. Let me sign up. All right. Let me show you what you got here. So there's nothing really unseen there before, okay? It's just a basic quiz page. You are going to have a few questions. This quiz here is actually a demo/test quiz, so this is not the one you are going to have to deal with, okay? But the one thing you're going to notice is that for each possible selection, you have also a text box available here. So this is where we're going to kind of like differentiate a little bit, diverge a little bit from the way that traditional quizzes work, okay? You have to choose an answer, of course. There's one answer correct, the rest are what we call distractors, okay? When you select an answer, for example, this one, if I say, I want to answer this here, and I cannot see from there. All right, the box collapses, meaning you don't have anything else to do. You chose that answer. For that answer, you are okay. Now, in the same question, there were 3 possible alternative answers. I want you to write briefly. It's not about writing a novel, okay? But I want you to write briefly in those text boxes why you didn't choose each of those possible answers. So, for example, this one here, I didn't choose it because, and avoid things like, for example, obviously wrong. You're going to see why, okay? Try to really justify why you dropped that potential answer, okay? Be as specific as you can. Be brief. Again, it's not about writing a 1-page essay. And when you're done, you submit all of this, and you're done with step 1 of the quiz. So it's somewhat like a regular quiz, except that it asks you to type a little bit more. This is why also we have fewer questions, so that you have time actually to focus on providing real justification. And again, providing good justification is important for the second step. It's also important as a part of your grade. We are going to grade you on the correctness of your answer. We are going to grade you on the quality of your justification, okay? And then step 2. Step 2 is going to be due for this week. It's going to be due Friday, 11:55, 11:59, whatever, p.m. Again, we are still tuning that, okay? You don't have much time to complete step 2. Why? Because step 2, you're going to, once you have completed the quiz step 1, you cannot reopen it, okay? It's going to tell you, hey, you took it already, wait for step 2 to be released. Once we switch to step 2, you click on the same URL, and you get the same quiz, the same question. But now, for each possible answer for each question, you are going to get an example of why one of your classmates actually rejected that alternative. So if there are 4 possible choices, you are going to get 4 reasons for which each of the choices are wrong. Obviously, some justifications are not going to be right. Okay, this is just you exchanging information with one another, like if you were discussing in class about a quiz, a question that we have on the board. So you have to filter through those justifications, determine whether they are useful or not to you, and then possibly change your answer. So you have 2 chances to get it right, including with feedback, a little bit of feedback from your peers. Once you submit, then you're done with the whole PLQ. And again, part of your grade is going to be your initial answer, your final answer. I'm going to assume that, the vast majority of students, if they don't get it right the first time, are going to get it right the second time after perusing, feedback from their peers, and then the quality of your justification. And that's it. All right? So, again, if you have feedback on this kind of stuff, it's always appreciated. Yeah?
When does step 2 open?
So step 2 is going to open at the end of step 1. Step 1 is due Thursday at midnight, pretty much. That means Thursday at midnight, step 2 will open until Friday at midnight.
Okay. I won't be in town. I won't have my computer on Thursday, but I will be Friday.
Okay, so if you can complete it sooner, then complete it sooner. Okay, first day is kind of just to leave you time, but after the lecture today, you should have everything you need. Okay? All right. Okay, resuming back the actual lecture, this is where we were at. We introduced a release in module 3. We talked about inheritance basic concepts, so nothing was really like too difficult so far, but I hope that you got the feeling already that it's a very simple mechanic, inheritance, but that opens up a lot of possibilities. What we are going to do today is we are going to start looking into the detail. the consequences of enabling inheritance. And more specifically, we are going to take a closer look at how inheritance works with constructors, or more accurately, how constructors work with inheritance. So we are going to talk again about constructor chaining, but it's going to be a different kind of chaining that happens between the subclass and its superclass. So before we jump into that, I want to make sure real quick that we are all on the same page with the chaining within a class. So a quick exercise / question here. We have a class something else. Let me run you through the code real quick. It has two private attributes, x and y, of data type int. We have a constructor here, a no-arg constructor, that just displays when it's executed, this is a no-arg constructor doing something. And then it delegates the rest of the work to the to-arg constructor by using the syntax. We have a one-arg constructor here that takes the parameter v, and it delegates also, and it displays this is a one-arg. So each of them is going to display a message so that we know when they get executed, just for debugging purpose. And those two are delegating to, respectively, the to-arg and the one-arg constructor. And this one is a to-arg constructor that displays again a message, then delegate to the no-arg constructor, and then assign x and y to the value of the parameter that you specified. So there are a few things that are wrong with this code. Take a minute and let me know what you catch. Yep, go ahead.
It's like an infinite loop because it keeps on calling, so it keeps on chaining itself.
Yeah. So one of the things we discussed, the idea was it's an infinite loop. Yeah, there's an infinite loop somewhere in there. Do you guys see it? Yeah.
You have to put the disk on the first line.
That's another good point. So the des call is not in the first line. What this is going to do? Okay. So it's going to do bad things for us. So yes, we need to fix that. We need to fix the infinite loop. Let's take a look at this together. So first one, if I try to compile this as it is, that's going to be your point that's going to pop up first with the compiler. The compiler is going to catch first that, you know what, we have 1, 2, 3 constructors, and yes, I can use this des syntax inside a constructor. That's the only place where I can use it. But I cannot use it after I've done already something in the constructor. So it has to be the very, very first thing, okay? As a matter of fact, I don't remember who I was working on that with, but one of you had a very interesting example where they were just doing something while they were passing the parameters to the call to des. And that was enough for the compiler to tell us, no, the call to des has to be the first thing. You cannot even do complicated things on the parameter. You could have an argument that is, 2 plus 3. That's easy to evaluate. But if it goes beyond that, you can very, very, very easily get the compiler warning that's going to tell you, no, you cannot do that. Too much work before to delegate. So absolutely, the first point here is we need to feng shui a little the stuff. Okay? So we are going to move those calls and make sure that they are all first in their respective constructors. All right, here we are. So this one has been moved to the top here. If I can get back my pointer. Maybe not. There we go. This one has been moved to the top. Same here, same here. We still have problems. This is when we go to your remark. The remark was there is a sort of infinite loop going on somewhere. Everybody is delegating, passing the bucket alongside. It's not going to go anywhere. Well, if we try to compile this, the compiler is actually smart enough to realize that this is going to happen at runtime. And the error message we get is recursive constructor invocation. So whenever you get a message like that that talks about a recursive constructor invocation, you have to make sure that the chaining is actually not cyclic. This is the issue, okay? Like the no-arg constructor calls the to-arg constructor, the to-arg constructor calls the zero-arg constructor, the no-arg constructor calls again. These two are never going to get anything done, okay? So, and that's just an example because this is a real spaghetti dish here. It's going like every which way. There's nothing that works here actually that gets the job done. So the first level of recursion that we have is the one that's highlighted in yellow. Something else, one arg constructor calls the one arg constructor from the same class. This is direct recursion. This constructor calls itself again and again and again without stopping. So we can fix that. We can eliminate that, okay? And we can say, for example, oh yeah, I was not paying attention. When you call me with one argument, what I really wanted to do is call the two arg constructor with two arguments. And then this is when we have the second level of recursion that kicks in. That was like the most straightforward recursion. The constructor calls itself. Well, here we still have a recursive constructor invocation, but this time it's indirect. Okay, meaning that when you call the no arg or when you call the one arg, you end up calling the two arg version, which calls the no arg, which calls the two arg, and we end up in that same cycle that we described initially. All right. So no matter which one you call, you end up in that stable configuration, which is an infinite loop bouncing back and forth between the no arg constructor and the two arg constructor. So in that little example, there was pretty much everything that could go wrong based on what we already discussed. So here's a fixed version. Okay, the fixed version is doing its delegation to the two arg constructor. The two arg constructor actually does some work and doesn't delegate itself to somebody else. The des parenthesis syntax is used first thing in every one of the constructor. So we got every rule that we set for the usage of the des syntax covered. I'm going to introduce a new keyword very soon. That new keyword is going to pretty much follow the same rules. Okay? And we are going to have even additional rules on top of that. But this is why I wanted to have all of this fresh and clear in everybody's mind. If there is anything on this slide that raises question, please ask them right now. All right. So going back to the new stuff. The first thing we have to ask ourselves is, when we introduce inheritance, I was careful to say attributes and methods are what's inherited. Okay? You define a subclass, you get all of the attribute, all of the method of your superclass. Technically, it's not 100% correct for what I said, because constructors are considered methods. They are considered special method. So based on what I said last time, it would be natural for anybody in this room to think, well, he said all the methods are inherited, so the constructors are also inherited. Constructors are never inherited. That's the exception. The attributes, yes, they go from the superclass to the subclass, perfect. The other method, I should call them, yes, the regular method, getter, accessors, and stuff like that. Constructors, no. So what do we do if we don't inherit a constructor? How is that going to work? Well, constructors can be called explicitly or implicitly. So we already talked about implicit stuff that Java does for you, right? Like, for example, if you have a class and that class has no constructor, Java is going to inject for you a default no arg constructor that takes no argument and does nothing. Okay. So that would be what I mean by implicit. Explicit means, sometimes inside of our code we have used the des keyword with the parenthesis syntax to say, I want to call that constructor. Or when you create an object, you say new, name of the class, parenthesis, and then you specify your argument. You are telling pretty much which constructor you are going to call. That's explicit. In our case here, we have a new keyword called super. So super is like the keyword des. It's the same kind of meaning. The keyword super, however, refers to the superclass. The des keyword refers to des class, the class where you are executing the current code. The keyword super, always a superclass. And there's going to be, as well, two syntaxes. We're going to see that on the next slide, okay? But super is how you are going to call explicitly from the subclass, and more specifically from a constructor in the subclass, one of the constructors of your superclass. So if I'm writing the code for a constructor in this class right here, right? If I want to call a constructor from the same class, des, parenthesis. If I want to call a constructor from my superclass, super, parenthesis, notation. Okay? And that's the way to call explicitly. And then there are some rules that make Java call implicitly constructors. Let's say that I have a class that has no constructor whatsoever, okay? And then I have a superclass. So let's call the first class faculty. The superclass of faculty is employee, okay? Faculty is a subclass of employee, employee is a superclass of faculty, etc. So if I have no constructor in the class faculty and no constructor in the superclass employee, you know that there is some default constructor that is injected, right? In both classes, actually. And then the thing that I'm going to add on top of that is that there is also some default way that Java is going to chain together the constructors from the subclasses with the constructor of their corresponding superclass. So when you create an object of class employee, the superclass, its default constructor kicks in. When you create an object of class faculty, its default constructor kicks in, and by default again, it calls immediately, first thing it does, it calls the superclass constructor. The logic to remember that is always to go back to something physical, okay? Object-oriented programming is based on a lot of analogies with actually pragmatic stuff, physical stuff. Let's say that you have a building, okay? And you have classrooms inside the building. That's the example I like to always take. When you say, I'm going to construct a classroom object, it's implied that if the classroom object somehow inherits from the building object, it's a form of construction, structure, then when you build a classroom, you have to build actually the building around it. That's it. That's when you bring it back to an example like that, that's really concrete common sense, then the other way around makes sense. When you are constructing objects and calling constructors, you call a constructor on your object. If that object is of a class that has a superclass, first I need to lay the foundation. Okay? So I create everything that's related to the superclass, then I create everything that's related to the subclass. Okay. So this is a new type of constructor chaining. We have a new keyword to implement it. Okay? We are going to explicitly chain, so I already explained the implicit. The explicitly will be with the syntax super followed by parentheses, just like we did with the des followed by parentheses. So strong, very, very strong analogy, down to, as we are going to see, some of the rules. This example here on that slide is actually the example that I kind of illustrated informally, verbally, where we have nothing. We have no constructor in a class. So let's take a look together. We have a public A class. That class features no constructor, so we know that it's equivalent to, I'm pointing at the wrong stuff here, sorry about that. So I'm going to move that laser pointer to the top and stop pointing at that box, and instead I'm going to tell you about that class A. That class A has no constructor, so that means that by default Java inject a no-arg default constructor, and this is what it's going to look like. Now I can point to that box, okay? So this is our default no-arg constructor that is automatically generated by Java, and there is one more step that we never mentioned until now. It's when you have a constructor in a subclass, in something that is a subclass of something else, okay? And you have nothing in that constructor, or more specifically, you don't use the keyword super, you don't use the keyword des explicitly, then automatically Java injects a call to the super keyword followed by empty parentheses. So what is this about? This is about actually making sure that no matter what happens, a constructor from a subclass always first calls the constructor of the superclass. And if you don't say anything about which constructor of the superclass to call, Java by default is going to call the one with no arg. So that's going to happen in your default constructor, no arg constructor. If you have a constructor, if you write a constructor for the class A, for example, a constructor that takes a double, okay? You take a double, so you have a constructor this time. You have maybe some code here, some statement inside the constructor. You didn't delegate at all. You didn't use a des keyword to delegate within the class. You didn't explicitly choose a constructor in the superclass to delegate to. If you are not doing either of those things, then automatically Java is going to say, well, when I call des constructor, it's going to first defer to the constructor of the superclass. Which one? Well, since you didn't tell me anything, I'm going to assume the no-arg constructor. So we have two levels now of Java doing default things for us. And those two levels of doing default things for us overlap with one another. So there are some times where Java generates that constructor for you, and inside that constructor it generates that call to the superclass constructor. That's not the only thing that you can do with the super keyword. Just like the des keyword, it has two syntaxes. I already mentioned that. One is followed by parentheses. That one appends only inside constructors, and it allows you to call a constructor of the superclass. The second syntax is super followed by a dot, and then followed by the name of an attribute or the name of a method. It's exactly the same meaning than when we use a des keyword followed by a dot. The idea is I'm clarifying the name of something. I want to talk about an attribute, but I want to make sure you understand that from my position here, from the code I'm writing right now, if I write super dot, for example, my data, that means my superclass defined an attribute my data. And if I ever have a parameter or local variable named also my data that would overshadow it, I want you to go past that and find the attribute in the superclass. So super dot name of a method, super dot name of an attribute is just clarification. Just like des dot the name of a method, des dot the name of an attribute is to clarify when you have hidden names. And the parentheses, just to chain constructors. So the des dot syntax can appear anywhere in the code of any method, constructors or not constructors, just like we've done before. Well, everything we've done before with the des applies also to the keyword super. The rule about using super, they are strangely familiar, okay? You must use the keyword super to call the superclass constructor only from a subclass constructor. So if you didn't have a superclass and you try to use the keyword super, okay, that would kind of work because of something I didn't mention yet, but it would not be logical, okay? You want to refer to your superclass. The second rule is you use the name super instead of using the name of your superclass. Every semester there's at least one or two students that ask that question or make that mistake. I already had a question about that when we introduced the keyword des. The question being, instead of using des, can't I just use the name of the class that I'm trying to call a constructor from? And the answer is no. It's just Java syntax. You have to use the keyword des. If you want to refer to your superclass, same thing. You have to use the keyword super. And then, and this one is going to be interesting a little later on, if you are going to use super, that needs to be the first thing you do in a constructor. And we're familiar with that rule, right? It was exactly the same rule with the des parentheses syntax. If you are going to delegate to a constructor inside your class with des, you have to do that first thing in your constructor. If you are going to delegate to a superclass constructor, you have to do that first thing in your constructor. Yeah, question?
So can you not do both?
You can, and we're going to see how. But it's going to be a little, I wouldn't say tricky, but you have to be careful, okay? But you put your finger exactly on the sore wound and put like a grain of salt in it. We have to make a choice. Apparently we cannot do both. Okay, at least in one constructor. I cannot call des and then call super, or call super and then call des, because I'm violating one of the two rules, the rule for des or the rule for super. But somehow, I want to be able to do both type of delegation. So the answer to your question is, can you do both inside one constructor? No. Can you do both actually between a subclass and a superclass? Yes, you can mix and match, but you have to be careful to avoid a few problems that we are going to discuss very soon. Okay? So let's see if that stuff actually makes sense. That's always a plus, right? Here's a piece of code. Let me run you through it. And then I'm going to ask you to trace it, not implement it if you have your laptop. Leave the laptop for now, but just trace it based on what we just discussed. And if you need a reminder, if you have questions, please feel free to ask them now. Okay? So we have a public class main at the top here, with a main method inside of it that creates an object of class faculty. And that's it. Very complicated. And then we have 1, 2, 3 classes. So those 3 classes, it doesn't matter if they are public or non-public. I just realized that one of them is public, the others are not. I'll fix that in the slide. Those 3 classes could be in their own Java file in the same folder. We are going to have a class person that represent all of the information we have to model a person in our application. Then a class employee that extends person. And then a class faculty that extends employee. So it goes person, that's the most superclass, employee, and then faculty is a special type of employee. Okay? Inside those classes, what do we have? We have pretty much only one thing, well, 2 things here. We have a constructor in the class person, a no-arg constructor, that just displays the word dog. Doesn't matter what it displays. What we're going to do is we're going to try to figure out the order in which all of those constructors are getting executed. So I just need each of them to display a trace on the screen, to display something that tells me this is when I executed, before that one and after that one. Similarly, in the employee, I'm going to first delegate to the one-arg constructor in the class employee. All right, so this is my one-arg constructor. My one-arg constructor takes a string and displays that string on the screen. So here, when I delegate, I pass the string squirrel, which means that when that one-arg constructor will execute, it will display the word squirrel on the screen. After I'm done with this, I'm going to display the word cat inside the no-arg constructor here. And then the no-arg constructor will be done. Inside the class faculty, I have just one no-arg constructor that displays the word robot on the screen. And you probably guessed the question by now. I want you to check, your understanding of the order in which those constructors are going to call each other. And I give you 4 propositions. So either you try to come up to the solution by tracing the code, which I recommend, or you try each of the 4 solutions and you check if they make sense, if this is a possible actually order for the stuff to execute in. Take a minute. Give me a little sign when you're done, like, thumbs up or whatever, so that I know when the majority are okay and ready to move on. So execution starts here. If you get lost at some point, you have like a brain overflow looking at this example, give me also a sign, like a little thumbs down, so that I get a feel also of those who are done and those who are ready to jump out of the window. Bless you. All right. So How many people decided that A was a correct answer? A few? Okay. What about, so it's not A, sorry. What about B? Now people have a cold hand there, like I'm not raising my hand, it's going to say it's not B. Well, yeah, okay, that's not B either. But I'm not going to do that a third time in a row, so what about C? Yeah, you guys are not going to play anymore if I play like that. Fair enough. It's not C either, so it's not D either. No, just joking. It is D. So this is a great example. I'm going to upload the code, by the way, on Canvas. Okay, I'm going to upload that code on Canvas so that after we are done doing the lecture thing with the PowerPoint slides, etc., you can actually download that code and redo what I'm about to do with you, but PowerPoint version with the debugger. Okay, because the debugger, I told you that at the beginning, it's your best friend when you have a piece of code, you're not quite sure how the piece of code behaves. The debugger allows you to step by step through it and see exactly what Java is going to do with that code. Okay, so in our case, we want to see the order in which the different constructors are called. Step through, step through, step through. We are going to see that happen live in front of us. Okay, so what we're going to do, we're going to do exactly what the debugger is going to do, but we're going to do it with a slide so that I can easily, highlight code, comment, and stuff like that. So it's going to be the first step. But then I will encourage you to redo this with the debugger at home. So execution, like I said, starts here. The first thing we do is the first statement in the main method. We create a new object in the main method. We create an object of the class faculty. Okay. So 4 steps, right? When you create an object, the reference variable is declared, so it comes into existence. Then you create the object in the heap. Then you call the constructor, and this is where we are at right now. The last step will be assign the reference to the newly created object inside the variable, in this case, obj, object. So we are on step 3 of this little thing, and we are right now running the constructor from the class faculty. Which one? Well, since we didn't pass any arguments here, we are going to run the noarg constructor. Good thing, because there's only one constructor in that class, and it's a noarg constructor. So everything is fitting well. That is going to display, so I change the message so that you can see an order. Okay? So we are entering the faculty constructor, and the first reflex is to say, this is going to display system.out.println, blah, blah, blah. No, not yet. What's happening here? We are executing a constructor in a class that happens to be a subclass of, in this case, employee, right? So I know that the class is a subclass of employee. Java knows it. So instead of starting with the execution right away, what it's going to do, it's going to instead inject in the code of that constructor a call to super empty parentheses. So it's like if right here we injected super, open parentheses, close parentheses, semicolon. The idea here is that if you don't delegate to anybody with this or super explicitly, implicitly I'm going to connect you to your superclass constructor. Okay, so that call to super that is invisible here is going to get executed, and we are jumping here to the superclass employee, and because we called super with empty parentheses, well, Java called it on our behalf, okay? We are calling the noarg constructor in the superclass employee. What's happening here? Do I do the same thing again? Do I go and say I'm going to call super without argument because what? No. I delegate already explicitly here. This time I use the des keyword to delegate to another constructor inside the class employee. Okay, des stays within the class where you use it. So the next thing that's happening here is a chain explicitly with another employee constructor. Which one? The onearg constructor. So that's going to be this guy here. So step 5 of this whole thing is now I'm entering the onearg constructor for the class employee. and I'm about to execute it. Except that what? Except that I check the first statement. It's a system.out.println, so there's no explicit delegation with this. There's no explicit delegation with super. So what happens? Java says, somehow I need to connect this constructor to its superclass. And I'm going to inject super, open parenthesis, close parenthesis, semicolon as the first statement here in this constructor. So again, we are going to make another jump because we extend person. We are going to call super empty parentheses, which correspond to the noarg constructor from the superclass person. So step number 6, we made another jump here to this particular constructor. And then what happens here? Well, the slide is going to lie a little bit to you, but since I'm going to tell you how it lies to you, it's not bad, right? So the slide is going to say, now finally we execute system.out.println. But that doesn't really make sense, right? It kind of makes sense based on what I said, because we don't have the keyword extends here. So you could rationalize it by saying, since the class person doesn't extend any superclass, right? The fact that here I don't start with an explicit delegation with des or super is not going to cause Java to inject a call to super empty parentheses. So that's actually a good understanding at this level where we are at right now. I want to go a little deeper. I want to use this opportunity to introduce another ID. The other ID I want to introduce is that when you don't extend a class, remember you can have only one superclass, one direct superclass, right? When you don't specify a direct superclass, again, Java does something implicitly for you. It's going to say that any class that doesn't extend anything using the keyword extends is by default extending this one super uber class called object with an uppercase O. So there is this class in the Java development kit, in the JDK library, called object. And every single class that we wrote before we heard about inheritance, before we heard about the keyword extends, by default was actually already extending, inheriting from the class object. So that means that if we want to be like very accurate on this slide, well, technically I don't extend explicitly, but implicitly Java will extend the class object. So again, implicitly, Java is going to say, well, I need to connect you to your superclass. So it's going to call super empty parentheses, which is going to trigger, again, a constructor in the superclass, the one with no argument. And then does it keep on going like this? No. The class object inside the JDK is the one class in Java, the only class in Java you're going to ever encounter that has no superclass. This is where it ends. Okay, so when we finally bubble up all the way up to the class object, then the class object says, you know, it's me, object, I'm in charge, and nobody is going to delegate anymore. I'm going to take care of building pretty much what is a basic, the most fundamental basic object in Java, and then I'm going to return from my constructor, and we are going to be ready here to do system.out.println. So between step 6 and 7, there's one more thing that happened. I'm introducing it right now. We're going to talk again about it, later. But for this example, yeah, let's say that 6, 7, something happened. But now let's focus on the object, on the order in which our constructors, the ones that we wrote, execute. And talking of which, now I'm executing my code, finally. So system.out.println, in this case, number 1, the person's noarg constructor gets executed. And then I reach the end of my constructor for the class person. What happens? I return. Return to where? Return to here, because this was the location where there was that implicit call to super that catapulted me all the way here, and then this happened, and I returned after the call to super to execute, just in time to execute, system.out.println of the string s. The string s that was passed to me is number 2, invoke employees overloaded constructor. Okay? And then I reach the end of this constructor. I return. Return to where? Return to after the delegation here using the des keyword. So now that I'm done delegating to another constructor in the class, this other constructor did its job. Now I can do more stuff. For example, displaying on the screen, number 3, employees no arg constructor executes. And then I reach the end of my constructor. Again, I return. So where was I called from? I was called from right here. So now I'm going to execute the system.out.println for faculties no arg constructor is finally called. Okay? First contact with des. You know about this des keyword. By now, I would say 70% of you are rock solid on the des keyword, approximately. Okay? So we added the super keyword. We run through that example. If I bombard you with a similar example, let's say tomorrow, in a quiz or anything graded, how many of you feel comfortable doing it? Okay. So I'm not going to ask how many of you doesn't feel comfortable. I'm thinking this is a majority right now. So that's all right. Give it a shot with the debugger first, before anything else, okay? And then, if that's still not clicking or you are really not feeling confident, let me know about it, okay? Because as you can guess, we can generate almost those kind of practice exercise, like automatically. We could write a computer program that would generate this kind of stuff for us and make like the delegation, etc. So no, I don't have that kind of computer program yet, but I can generate them by hand for you. So I can generate a few more practice exercise here if there is a need for it. Just let me hear it, okay? But generally, most of the time, if you get through the debugger step by step, take your time, study the slide, okay, you're going to be fine. But the first contact is a little overwhelming. That's normal. So finally, we get to your question, which was a good question, which was, so can we do both type of chaining at the same time? And the answer is yes, we can. We can definitely do the both type of chaining in a class. However, inside every single constructor, you have to watch out for that rule. Okay, the rule of the des syntax that says you have to be first, and the rule of the super syntax that say you have to be first. Obviously, both of these statements cannot be first in the same constructor. So it's one or the other, or none. These are your three choices. Every time you write a constructor, I use nothing explicitly, I use des explicitly, or I use super instead explicitly. All right. So this is where it's going to get interesting, because we are going to have to kind of like work around things a little bit, make them how to say, comfy there. How do we work around this constraint? The fact that we cannot use super and des, in the same constructor. So the general pattern, and it's really kind of like a vague pattern. I don't want to force you to always do things that way, but it's just one way to do it that works. So I'm going to start introducing it, and you can use it as a pattern. Once you understand it very well, then you are going to be able to generate your own patterns, okay? The first step is you are going in a class. Let's say I'm writing the class faculty. I'm going to chain with the des syntax all my constructor in the class to one or two or three, like at least one of them. So at least one of the constructor is not going to do any chaining for now, and all the other constructors, in order to avoid code redundancy, I'm going to make them chain with that constructor, that other constructor. That's the first step. We've done that. Second step. Let's say that I have only one of those constructors that doesn't do chaining with des, the one that finally does the job, okay, gets the job done. By definition, this one is not delegating to another constructor inside the class. So by definition, this one is not using explicit delegation with the des keyword. Okay, so guess what? This is an opportunity. This is an opportunity for me to either let Java introduce the super keyword right there, because I'm not delegating with this, or to do it myself explicitly by writing super parentheses and maybe empty parentheses if I want to invoke the superclass noarg, or maybe I pass some arguments, I decide, okay? So either implicitly or explicitly, This is one constructor in my class faculty that's going to connect to the superclass. So visualize this by layers, right? Inside the subclass faculty, I can have 50 different constructors. All of these are calling one another. I'm avoiding cycles, right? Because if I don't avoid cycles, there's going to be some times where the constructor never end their job. But they call one another, and let's say to simplify, there is only one of them that doesn't delegate any further. Well, that guy is the one that's going to delegate to the superclass. That's it. So that's going to be your liaison, your link from the subclass constructors, all of them, to the superclass constructor, to one of them. So generally, we like to do that with the constructor that takes the most parameters. You've seen that trend already when we learned to use the keyword des, right? Generally, a no-arg constructor is going to say, you know what? You didn't give me anything, so I'm going to call that 5-arg constructor, and I'm going to make up values for each of the 5 args. Not the other way around, okay? So it's going to be the same idea here, and generally, those constructors that allow you to specify a lot of things, to customize a lot of things in your object, they are the ones that every other constructor from the same class end up calling, and they are the ones who end up making the link with the superclass constructors. So here's an example showing what we were just talking about. So we have a class here, something different, contains a private attribute of type int named z, contains a no-arg constructor that simply delegate to the 1-arg constructor with a default value of 23, whatever that means. And then we have a 1-arg constructor that takes a value as parameter and assigns it to the parameter, to the attribute z. Sorry. So basic stuff that we have been playing with for a few weeks now. What about this side? Public class something else extends something different. Okay, so this is a subclass, this is a superclass. In the subclass, I have 2 attributes, x and y, private of type int as well. I have a bunch of constructors, a no-arg constructor, and this example should look somewhat familiar, but a no-arg constructor that is calling the 2-arg constructor and then displaying, well, the no-arg constructor was executing. And then a 1-arg constructor that calls also the 2-arg constructor and specify twice the value that you were giving to it. And then a 2-arg constructor that this time assign to x and y their value, display a message. But before that, if I didn't have this super line that I'm pointing at right now, if I didn't have this super line, there would be an implicit call to super empty parentheses. Why? Because this constructor here belongs in a subclass of something, and it doesn't delegate with this explicitly or implicitly. So this is where Java is going to do the implicit delegation. I chose to do it explicitly. I wrote myself the super keyword, and I decided that I'm not going to call the no-arg constructor. I'm going to call the 1-arg constructor and give it the sum of px and py, which are my parameters. Okay? So that constructor is going to refer and delegate to this constructor here. So let's take a few examples. If I create an object of class something different, okay, forget about inheritance for a second. If I call the no-arg constructor, it calls the 1-arg constructor and creates an object with 23 inside of the attribute z. If I call directly the 1-arg constructor with the value 42, then it's going to create an object with the value 42 inside of it. Okay? Basic stuff. Now that I have a subclass in the game, what happens if I try to create an object of the subclass using the no-arg constructor? First thing, the no-arg constructor here calls the 2-arg constructor from the same class. So with the values 42 and 99. So I'm going to add together 42 and 99, 141, and I'm going to pass that to this constructor. So the value for z will be 141, and then px was 42 is going to be assigned to x, py was 99, I think, is going to be assigned to y, and then I display something and I return. Okay? So again, the same kind of chaining that we had in the previous exercise, but I want to really illustrate the pattern where if I call this constructor, it goes here and then goes there. If I call the second constructor here, it delegates also to the toArg, and the toArg is the one that delegates to the superclass. So it's kind of like you build kind of pathways to your superclass by delegating carefully among your constructors. That's the next thing we are going to really focus on, okay? I pretty much already exposed it to you, but what I mean is that this is a skill you need to acquire. This is where you need to ask questions. This is what you need to practice. This is what you need to ask me if you don't have enough practice exercise about, okay? There is something like that that's going to pop up in the quiz, in the exam, obviously. I want to make sure everybody is capable of tracing that kind of code, okay? If you cannot trace it, you cannot write it. So before even I ask you to write it, I want to make sure you understand it. And then I'm going to ask you to write code like that. We're going to write it together during live coding. And hopefully you're going to get so familiar with it that you are bored with it by the time we get to the final exam. Okay? All right. So, okay, we already did that. We traced pretty much by hand. I'm going to upload this code too, so that you can have a look at it. Last thing we're going to talk about, I want to kind of put the last nail on the coffin of the topic about, those default constructors that are generated, okay? So I'm going to show you some, what I call troublesome code, and then we are going to fix it together. And once again, it's one of those examples where if you get it the first time I present it like that, perfect, okay? If you don't get it, don't freak out. It's going to be a little overwhelming the first time you encounter the example, but almost everything in this lecture is initially overwhelming, so that just means that you need to reread it calmly, while you restudy the slide. That's all. You don't have to do that for every lecture. Some lectures are like straightforward. This one is a little less straightforward, so be warned about this, okay? Let's take an example, again, as trivial as we can make it, so that the only complexity comes actually from the mechanics, the object-oriented programming mechanics themselves. We have a class apple. The class apple extends the class fruit. So apple is a subclass, fruit is a superclass. And I cannot make it more trivial than this. The class apple has nothing inside of it. No attribute, no method, no constructor. So that should raise a red flag, right? If it has no constructor, what does that mean? That it has a constructor. It's just not showing up there. It has a default no-R constructor, right? All right. And that's going to be part of our problem. And then here we have the class fruit, which is a superclass. The public fruit string name. So we have one constructor that takes actually a string as parameter. And then we just do a system.outprintln, with a message that says the fruits constructor has been invoked, and that's it. Okay, that's all we have. If I try to compile this, this is what I'm going to get. And part of my goal with this slide is to give you a booster shot, pretty much, on the kind of compilation errors that you're going to get. Okay? The worst thing you can do with compilation error message is ignore them totally. On the other hand, I do understand, some of you are going to tell me, but sometimes I read the compilation error, and it makes no sense. Yes, they are not necessarily easy to read. They are not meant for beginner. They are not beginner friendly. Okay, but this is why we look at some of those errors more specifically during the lecture, because then you know what to expect. Even if the message is not clear, you know that when you get that unclear message, it refers to a situation that we covered in the lecture. So what is the error message we get? On line 22, wherever that is, okay, error, constructor fruit in class fruit cannot be applied to given types. So it tells us more specifically that the error was discovered when Java was parsing the beginning of the class apple, okay, and it says what was required is a string. What I found is no argument. And that can be a little unsettling, okay? This is pretty much the one error message that I could find that requires you to understand everything we covered this lecture to make sense of it. So it's a good checkpoint, okay? Let's use that for practice. So, first is complaining about the constructor fruit. And then it's complaining about the constructor fruit inside the class apple. Well, that by itself is a little troublesome, okay? Inside the class apple, I have nothing at all, except that as we discussed, when you have nothing at all, that means that you have something that is inserted by default. So let's take a look at this. What is going to be inserted by default here? A default no-arg constructor that does nothing. If it does nothing, if there's nothing in the code of that no-arg constructor, that means it doesn't call explicitly this, it doesn't call explicitly super. So what happens when you have a constructor in a subclass that doesn't explicitly delegate to this or super? Java kicks in and says, oh, I'm going to make you delegate to super empty parentheses. So we have two things that are inserted here automatically. The default no-arg constructor, and because that default no-arg constructor is empty, the first thing we're going to do inside of it is a call to super parentheses parentheses. And there lies the problem. What Java is doing by default for us, it's the most basic version of connecting, a subclass constructor to a superclass constructor. I'm going to call the superclass constructors no-arg constructor. And then you look at your superclass, the class fruit, and you realize that there is only one constructor inside of it. And that constructor is definitely not a no-arg constructor. It takes one argument. So here's the deal. You are calling, and you should have air quotes around it, okay? We are calling super without parameter, and the superclass has no-arg constructor to offer to us. That's the syntax error. We've got a syntax error on code that we didn't write. There should be an achievement for that. You don't write something and you still get it wrong. This is awesome if you think about it, okay? So, it's not entirely our fault. It's Java's fault, of course. So we can try to fix the problem. And this is just an excuse for us to tinker a little bit more with the code, okay? So I'm putting here, since the problem is, I tried to call a no-arg constructor and I could not find a no-arg constructor. Fine, if you want a no-arg constructor, here's the no-arg constructor compiler. So I give now to the class fruit a no-arg constructor, and since I don't know exactly what to do, I'm going to set up a default value. So what the one-arg constructor takes is the name of the fruit, I guess the type of the fruit, right? So I'm going to pass an empty string. So I have a no-arg constructor that delegates to the one-arg constructor, and that passes an empty string. That, by itself, is enough to make the compiler shut up and be happy. Okay, now we can let the compiler do all of its default work here in the class Apple. We just provided pretty much a segue into the constructor chaining path that it was trying to use. All right, so this is going to work. What if we write actually our default constructor explicitly? So public apple no-arg, and then I'm going to throw in, so it's not going to be default anymore, I'm going to throw in a little text here that says the apple's no-arg constructor is invoked. So I replace pretty much the default no-arg constructor by a no-arg constructor of my own design in the class apple. And then I put explicitly again the call to super nothing in between the parentheses. So what I did here is I pretty much wrote what Java, with the exception of the system.app.println message, this is pretty much what Java injected for free, in my code for me. So I wrote it explicitly, and I can tell here that this is the part that caused problem before, but now that I have this no-arg constructor, everything is shiny. Another way we could have solved this is by going into the class Apple, and instead of calling a no-arg constructor here, okay, saying that Apple has a one-arg constructor, that one-arg constructor takes a name. The name is going to be passed to the superclass. The superclass has a one-arg constructor that takes a name. Everybody is happy. So this is another version. You see that I removed the no-arg constructor for fruit. I could have both implemented. I could have either one of them. Both versions would actually yield a solution that compiles. One thing that's interesting, I have a constructor here for the subclass, and the constructor for the subclass takes an argument, which is name, which I don't use at all in this class, okay, in the class Apple. I don't have an attribute to initialize with it. I don't pass it around to another constructor in the same class. I just require that argument because my superclass demands it. And that's going to be a pattern. That's going to be something that happens all the time. When you write a subclass, you look at the constructors in the superclass, and whatever the superclass needs as far as data goes, okay, you are going to have to pass it to it. Or you are going to have to make up values on the fly. So if you want to ask the user that creates an object of class faculty, for example, to specify an employee ID, you are going to have to do that because your superclass employee has an attribute employee ID, and the constructors of that class need an employee ID to be able to initialize it properly. So it's kind of, again, a form of delegation of responsibilities. All right? I'm sitting here, and I need 3 things to be able to get my work done. Somebody subclasses me, and they need 2 more things. So now we're talking about 5 things that are necessary here. Another level of subclass, that subclass needs 1 more attribute, for example, or whatever, to be initialized. Now we're up to 6. So the more you go down in the subclasses, the more you're going to ask information from the constructor, okay? So that you can use some of that information, sometimes it's just a little bit, and then pass the majority of that information upstream to your superclass, and then to the superclass of your superclass, and so on, so forth, okay? It's not always that crazy, okay? It's not always that crazy because sometimes the subclass is going to decide, you know what, those 5 attributes that my superclass needs, I'm going to make up 4 of them. So I am only left with asking the user through the constructor to give me 1 of the attribute. So it's not going to be always like exponentially growing like that, but it's a matter of responsibility. The subclass is responsible for collecting all the data that it needs and that the superclass needs. The superclass is responsible for collecting all the data it needs and its own superclass needs. And it kind of propagate like that, like a chain. And we can end up with some, long list of argument for a constructor. You had a question?
Yeah. So in the class Apple, so does Java not add a default constructor on its own? Like say that because we explicitly defined a Apple with constructor with 1 argument or 1 parameter. So does Java not implicitly declare no arg1?
So very good question. Just for the recording, okay? The question is, don't we have a default no-arg constructor generated by the compiler in the class Apple? Okay, because we provided a constructor, but we still have those default constructors generated, right? No. So the rule is, if you provide no constructor whatsoever, the compiler steps in, and provides you at least with a default constructor, because there cannot be a class without constructor at all. But if you provide me 1 constructor, whether it is no arg, 3 arg, 2 args, 5 arg, 1,000,000 args, whatever, then you did your job as a programmer. You told me pretty much, these are the constructors that I want. And Java backs off and say, I'm not going to add any more to that. So the only job, the easy way to remember that is, the only reason Java would insert a default no-arg constructor in your code is because it didn't find a constructor at all in that class. That's it. But that question is also interesting from another perspective, the perspective of how do I study for this stuff, okay? You see how we have been growing a list of rules. And those rules kind of interact with one another, right? So how you are going to internalize this is really something different from student to student. I could present you the same material 3 or 4 different ways. After that, I would probably run out of ideas and would have to find like a different way to go about it. But the bottom line is that when you are trying to internalize that, you are going to have to maybe go in this classroom, for example, 10 different ways. So what you need to do for this is whatever you need to do when you memorize things, index card, list, rewrite it, etc. Memorize those rules. This has nothing to do with code, just the rules themselves. If you know the rules, then the coding is going to be easy. If you jump into the coding, like for example, let's say I release the next practice test, and you jump into that trying to get that working without actually knowing the rules, it's going to be hell. Okay? This is going to the point in this class where we have so many little moving parts, new concepts, etc., interacting with one another, that if you don't invest the time to clarify that big picture in your head, then everything else is going to start falling apart. Okay? I'm not trying to scare you. I'm just trying to give you a warning, a heads up, so that you know when it's moment, to do, maybe you're studying a little differently for this module than you did before, and adapt, okay, to the difficulty of the module. Okay. We are going to stop here. It's actually a good point to stop. Next time, I'll start the session with a little bit of live coding. Okay, and the live coding will allow us to kind of tie up together everything that we talked about during this session. Thank you for your attention.